Hello everyone, this time we will discuss the higher order derivatives, the implicit differentiation. Please subscribe my channel.
This implicit differentiation, what is this all about? This part of the higher order derivative. Okay, so consider the graph of the equation. We have here a circle with a tangent line, x squared plus y squared equals 64. The radius here is 8. So we have a line tangent to this circle. So how you're going to find the equation of this line? So if we have two variables here involved, so you're going to apply the higher order derivative, specifically the implicit differentiation. So how can we use calculus to find the slope of the tangent line for a particular x and y on the circle? So we're going to apply implicit. What are the steps here? First, get the derivative of each term with respect to x. If the variable, if the variable to be differentiated is different and not x, so treat as u. Third, solve for the desired derivative. Again, get the derivative of each term with respect to x. And if the variable is not x, that is y, so you're going to treat that one as u. Then solve for the desired derivatives. So we have here, this is an example of an explicit function. So we have worked with function of the form y equals fx. So y is equal to 4x minus 5. Another is y equals x plus 3 over x squared. Y equals x squared plus x plus 6. So even when given 2x minus 3y plus 12, so you can solve for y. So that is 2/3 x minus 4. So this time, we have here a function, implicit function. Some functions cannot be readily solved for y. So we have here, example, y squared plus 3xy minus 6x squared equals 0. So it's very difficult to solve for y. Another here, x squared over 25 minus y squared over 1 to 1 is equal to 1. So for this, we can say y is given implicitly in terms of x. So we'll use the implicit differentiation to solve the y with respect to x. So we have an example here. Given 4xy minus 6y squared equals 10, we differentiate with respect to x on both sides of the equation. So first, derivative of the left side, and then derivative of the right side. So derivative of 4xy minus 6y squared is equal to the derivative of 10. So get the derivative. We apply the chain rule here or the product rule here. Derivative of 4x times y. This is your u. This is your v. So the derivative of 4x times y plus the derivative of y times 4x. Remember? So the derivative here is 4x times dy over dx. Okay, that's why we have derivative of 4x here is derivative of 4x dy over dx, since you cannot cancel this one. The add plus derivative of y times the derivative of 4x. The derivative of 4x is 4. So that's why we have here 4. We have here 4x. Okay. The derivative of y times the derivative of 4x. So derivative of 4x is 4. So that's why we have 4y. So 4y plus this one, 4x times dy dx. Then you get also the derivative of this one, negative 6 times y squared. So you have here your u and your v. So negative 6, up here, negative 6 times the derivative of y squared with respect to dx plus y squared times the derivative of negative 6 with respect to dx. So here, this is now negative 6 times y squared. So that's why we have here where did you get 12? That is from derivative of y squared is 2y times negative 6, so negative 12y. And since the derivative of 6 is 0, so you cancel the next term. So that's why the final answer is negative 12y times dy over dx. Using the chain rule. And the derivative of 10 is 0. The derivative of constant is always 0. Okay, so each time an expression has an y in it, so we can use the chain rule. So now we have the equation now. Find dy dx. So 4y plus 4x times dy dx minus 12y times dy dx equals 0. So you are going to equate solve for dy dx. So transpose this one. So transpose this term. So 4y equals 12y dy dx minus 4x dy dx. Our goal here is to solve for, to group, factor out. So factor out here, common is 12y minus 4x dy dx from here. So final answer here, solve for dy dx, that's 4y, this is 4y. 4y over 12y minus 4x. So this is now the final answer. So that is the dy over dx, implicit, since you cannot solve for y. Okay? So if you have comment, you have question, you may comment in our stream homepage. So we have your activity. Evaluate the first derivative by implicit differentiation of the following. So first, derivative with respect to x of 3x squared plus y squared. Apply the implicit. And then number 2, x plus y squared minus x minus y squared is equal to x4 plus y4. Find dy dx. Same with number 3. X is equal to sine times the quantity x plus y. Okay, thank you for listening. This is one of the applications in the part of the higher order derivative.
We hope that you found this video helpful. If you have any questions, please leave that in the comments below. You can recommend a topic to discuss in the future. Please watch my other math tutorial and don't forget to subscribe on my channel.